Good afternoon, guys. So I'm going to be doing a couple of problems from section 8.4. What I want to be able to do is just show you how the process works with solving compound inequalities and being able to actually work them out step by step. Please make sure that you do your homework before you start doing this. So if you have any questions, you could go ahead and use this as a tool to help you. Always double check your answers in the back of the book. And if you are completely stuck, remember, I'm always there before class. You could always stop by and talk to me really quick. So we're going to begin with problem number 30 for the book. I believe it's page 652. And what it's asking you to do is asking you to solve the given inequality, be able to get x by itself, right, to isolate it. The only way that we do that is we have to be able to recognize what's happening. So the first thing that I see that is happening to my variable is that it's being multiplied by this 2/3. The second thing that's happening to this variable is being added by 1. So I always get to recognize what's happening to this, and I do the opposite. So I'm going to do the subtraction property of equality. This simplifies to 0 because of the additive inverse. So now I get 2/3 x is strictly greater than -10. There are different ways of doing this following step. You could do the reciprocal of these two and multiply it to both sides. Or you could do what I'm about to do, which take the denominator, multiply it across first, and then you have 2x is greater than -30. Then you get to divide by 2. So you end up with x is strictly greater than -15. The way that that looks for us is that we get to do a number line here, and it's telling me let's see what number, what value is going to give me this statement to be true. So I'm looking for any x that's going to make this true, that's strictly greater than -15. So -15 is here, I have 0 here, and I have +15. And I'm telling you that at this point it's going to be an open interval, or it's going to be an open dot, and it's everything that's greater than that, so everything to the right of that. And the way that we describe that as an interval is that it's going to be open parentheses -15 comma to positive infinity, and we close it up. The second one is going to be the same steps. We get to use the addition property of equality, where I get to add 1 to both sides. This simplifies to 0, so I get 3/4 is greater than -9. I get to multiply the 4, so I end up with 3 is, I lost the next somewhere in there. So 3x is greater than -36. I get to divide both sides by +3, and I get that x is strictly greater than -12. I'm going to go ahead and put this now on the number line. So here's my number line, and I'm saying that at -12, 0, +12, at -12, it's going to be an open circle, and it's everything that is greater than -12. And the way that it's saying, it's a compound inequality. So what we're saying is that we're looking for this interval notation where it's going to make these two statements true at the same time. That's all I'm asking for this to happen. So the final solution to this is going to be the interval, where it's going to make both of these two. So you combine these two into one single interval, where you have -15 here, you have -12 here, you have 0, and then we'll just put a random number here like 15 that will represent the positives. And what I'm asking you to do is to put these two inequalities together, saying that what's going to make this statement to be true at the same time. And remember what we said. We said we had from 15 all the way up to positive infinity, and then we also had at 12 all the way up to positive infinity. To be able to represent any solution that's going to make this statement to be true, it has to satisfy both of them at the same time. The only one that does is the interval when we have an open circle at negative 12, and it's going to go all the way up to positive infinity, and then we close it there. The next one that I'm going to do, this is an OR statement. It's a disjunction, which is going to go away from each other. So you're going to have the outcome to be something like this, for example. And the way that it works is everything is the same, just basic math using all the properties that we talked about. So we get to use a division property of equality, where we get to divide both sides by 4. I end up with x is strictly less than negative 3. And the way that looks like is here's positive 3, here's 0, here's negative 3, and it's everything that is less than that, strictly less than that. Let's look at the next one. It says I have x is being divided by 2. To get rid of division, we multiply, so I'm going to take the 2, multiply it across, and I get x is greater than 8. On the number line, this is the way it looks like. So I have negative 8, 0, positive 8, anything that is greater than that. So now I'm going to put these two in the same number line just to see how they look. So we'll have negative 3, we'll have 0, and then we'll have positive 8. And what I'm saying is that when it's less than 3, it's going to be represented in this direction. And when it's greater than 8, it's going to be represented in this direction. And it's clearly evident that between negative 3 and 8, if I choose any of those solutions, it's not going to work. So the way that we represent this is through the interval of from negative infinity, comma, to negative 3, parentheses. And then we're going to say that it's going to be the union of the next set, which will be open parentheses 8 comma to positive infinity. And if I were to choose some points within here and some points within here, or I should say it's going to make the statement true. But if I were to choose any points that are between negative 3 and 8, it's not going to make the statement to be true. So now here's the next one. The next one is number 50. With number 50, what we want to do is we want to be able to isolate t by itself. And I'm starting to notice there's a couple of things that are happening to t. So for example, the first thing that I see is being multiplied by this negative 1, and then I'm subtracting 2. So I'm going to do the opposite now to be able to isolate the variable. So I'm going to do the addition property of equality, where I get to add 2 to the middle. Whatever I do to the middle, I do to the right, and I do to the left. It should be a 2, sorry. So now I end up with 4 is strictly less than and negative t, which is still less than 11. And now what I'm going to be able to do is use the division property of equality, where I get to divide by negative 1 to both sides. And I end up with negative 4 something to t, which is something to negative 11. Now the reason why I skipped that there, because the rule says if you divide by a negative number to get the variable by itself, like we just did right now, the signs will switch. And then that means that you're going to have to rewrite this with the least number or the smallest number to the left, and then the bigger number to the right. So I'm going to rewrite this to be negative 11. I'm going to read it. Okay, I'm going to read this in that direction. So negative 11 is less than or equal to t, and t is less than or equal to negative 4. If I were to graph that the way that it looks like this, negative 11, and then I have, give me another number, let's say -7, -4, and then we'll always put the 0 there just to give us. So what I'm saying is that t is going to be a closed circle at 11. It's going to be a closed circle at -4. No. It's actually going to be an open circle. I noticed that right now when I looked at it. I put the underline under it just to say what happened to the inequality. But then down here I put it as an equal sign, and it's not an equal sign. So let me change that really quick, and then let me rewrite this. Here we go. So it's going to be an open circle at -11, an open circle at -4, and it's everything that you see that's in between these two. Okay? The way that we want to be able to express this, an interval notation, is going to be open parentheses at -11, and then that's going to go all the way up to -4 with a parentheses there as well. And I think I have one more example, which is going to be number 70. I chose number 70 because it does have a fraction in the bottom, and I know sometimes we get ourselves a little confused as to how to do it. So I'll go ahead and do it for you just to help you out. You take the denominator and you multiply it to both sides. So you end up with -4 is strictly less than or equal to 5 minus 3x, which is less than or equal to 4. The next step is to be able to isolate the variable. I'm going to subtract 5 from all sides, from the left and right, and then I'm just going to go ahead and add. So I get -9 strictly less than or equal to -3x, which is strictly less than or equal to -1. Now I get to use a division property of equality, where I get to divide everything by -3. And now I have a negative divided by a negative, gives me a positive. 9 divided by 3 gives me 3. Remember, the sign changes because I divided by a negative number. The same thing with this one here. So it's greater than or equal to. Negative divided by negative is positive, so now we have 1/3. I'm going to rewrite this because the least number always has to go to the left hand side. So I have 1/3 is strictly less than or equal to x. X is strictly less than or equal to positive 3. And the way that we want to write this is going to be the set notation, right? It's an interval notation. It's going to be brackets 1/3, comma 3, and then we close it. The reason why you get to use the brackets as opposed to the parentheses is because this example actually does have the equal sign on the bottom of that inequality. So don't forget, always study, do your homework, participate in class. Any questions that you may have, please let me know, and I'll try to help you out the best way that I can, okay?